Welcome, everyone. Thank you for joining us today. I'm excited to kick off this presentation titled Connecting the World Through Data, Protocols, and Infrastructure. In this session, we'll explore how communication networks form the backbone of our interconnected world. We'll look at the key concepts behind data exchange, the protocols that make it possible, and the infrastructure that supports it all. Let's get started and see how these elements come together to keep us connected every day. Let's explore what a communication network really is. It forms the backbone of modern society, meaning it's essential for how we connect and operate today. It enables global communication, so people and organizations around the world can stay connected easily. It also allows for resource sharing, like printers, storage devices, and other peripherals, which makes working more efficient. Plus, it helps with centralized management of applications and data, keeping everything organized and accessible. Now, in simple terms, a communication network is a collection of computers, servers, mainframes, network devices, peripherals, or other devices all connected together. This connection allows them to share data seamlessly. Think of it as a digital highway system, connecting different points so information can flow smoothly from one device to another. Understanding this is crucial because networks are the foundation of how we communicate, share resources, and manage data in today's digital world. They keep everything running efficiently and securely. Now, let's take a closer look at the different types of networks. First up is the Metropolitan Area Network, or MAN. This type of network connects users with computer resources within a specific geographic area or region. Think of it as a network that covers a city or a large campus, providing fast and reliable connections for institutions or organizations within that area. Next, we have the Wide Area Network, or WAN. These networks span much larger geographic areas, such as entire countries or even continents. The most familiar example is the Internet itself, which links millions of devices across the globe. WANs are essential for connecting offices in different locations and supporting global communication. Finally, there's the Local Area Network, or LAN. This type is used to connect devices within a small, limited area like a home, a school, or an office building. LANs are typically faster and easier to manage, making them ideal for sharing resources and data within a close-knit environment. Understanding these different network types helps us see how connectivity is scaled and customized based on specific needs, whether local, regional, or worldwide. Each plays a vital role in enabling communication and resource sharing in our increasingly connected world. Let's take a closer look at some common network topologies. First up, we have the single cable topology, where a single cable connects all the devices in the network. This setup is simple and cost-effective, but it can be a point of failure if the cable breaks. Next, the bus topology features nodes that are interconnected fully, providing redundancy. This means if one connection fails, the network can still operate, which is crucial for reliability. Moving on, the mesh topology involves every node connecting directly to every other node, creating a highly robust network. This setup ensures maximum redundancy and fault tolerance, but it can be complex and costly to implement. Lastly, we have the star topology, where all devices connect to a central hub. This is very common because it's easy to manage and troubleshoot. If one device or connection has an issue, it doesn't affect the rest of the network. As we explore these topologies, keep in mind how each one impacts reliability, complexity, and scalability, which are key themes in designing effective networks. Let's take a closer look at the OSI model, which is fundamental to understanding how data travels across networks. Starting from the top, at layer 7, we have the application layer. This is where network processes interact directly with applications, like when you use a web browser or FTP client. It's essentially the point where user actions translate into network requests. Moving down to layer 6, the presentation layer handles data representation and encryption. Think of this as the translator and security guard, making sure data is in the right format and protected before it moves further along. Layer 5, the session layer, manages inter-host communication. It establishes, maintains, and ends conversations between devices, kind of like a referee ensuring a smooth exchange. Next is Layer 4, the transport layer. This is crucial because it guarantees end-to-end connections and reliability, typically through protocols like TCP or UDP. It ensures that data arrives intact and in the correct order. Layer 3, the network layer, is responsible for path determination and logical addressing, primarily using IP addresses. This is what helps data find its way across different networks to reach its destination. Moving down to Layer 2, the data link layer handles physical addressing using MAC addresses. It manages node-to-node data transfer within a local network. Finally, at the bottom, Layer 1, the physical layer, deals with the actual media, signals, and binary transmission. This is the physical hardware, cables, switches, and the electrical or optical signals that carry the data. Understanding these layers helps us see how complex data transfer actually is, but also how each layer plays a vital role in making our network communications seamless and reliable. Now, let's take a closer look at some of the essential network hardware that keeps our connections secure and efficient. First up is the firewall. Think of the firewall as a security guard for your network. It monitors and controls the traffic coming in and going out, making sure that unauthorized access is kept at bay. It's a key component in protecting your data and maintaining network integrity. Next, we have the modem. The modem is what allows your network to connect to your Internet Service Provider, or ISP. Its job is to modulate and demodulate signals, which essentially means converting digital data into signals that can travel over phone lines or cable, and then back again, making that Internet connection possible. Moving on, we have the switch. Switches are the devices that connect multiple devices within a single local area network, or LAN. They're quite intelligent, as they direct data only to the intended device, rather than broadcasting to everyone, which improves efficiency and speeds up communication within your network. Finally, the router. The router is the device that connects different networks together. It directs data packets between them, ensuring that information gets to the right destination. Whether it's linking your home network to the internet or connecting multiple office networks, the router is central to managing and directing traffic across networks. Together, these hardware components form the backbone of a reliable, secure, and well-functioning network, each playing a crucial role in supporting the overall infrastructure we rely on every day. Today, we're going to explore transmission media, which is essential for how data travels across networks. First, let's look at some examples of unguided media, which use electromagnetic waves to transmit information without physical cables. Infrared is one such example. You might have used it with remote controls. Then there are microwaves, which are used for satellite communications and some wireless links. Radio waves, including Wi-Fi, are perhaps the most familiar. They enable wireless internet connectivity in our homes and offices. Moving on to fiber optic cables, these use light to transmit data, offering the highest speed and security among transmission media. They're ideal for long-distance and high-bandwidth connections. Coaxial cables are another guided medium, often used for cable TV. They support high frequencies and are quite reliable. Twisted pair cables, which are very common, are affordable and widely used in Ethernet networks. Think about how your home connects to the internet. Overall, guided media involves signals that are directed through cables, providing more control and less interference. In contrast, wireless media are unguided. They rely on electromagnetic waves to transmit data through the air, offering greater flexibility, but sometimes more susceptibility to interference. Understanding these different types helps us choose the right transmission media based on our specific networking needs. Let's talk about some of the core concepts that help us protect our networks. First, availability, which is often addressed through DDoS protection. This ensures that our systems remain accessible even when under attack or experiencing high traffic. Next, integrity, achieved through hashing, helps us verify that data hasn't been tampered with or altered during transmission. Then, confidentiality, secured through encryption, keeps sensitive information private and protected from unauthorized access. Now, the key concepts here are that network security is all about the policies and practices we adopt to prevent and monitor unauthorized access, misuse, modification, or even denial of service attacks. It's about safeguarding not just the data, but the entire network infrastructure. When we talk about protecting the flow of information, it's essential to understand that network security isn't just a set of technical tools. It's a comprehensive approach that ensures our resources remain available, trustworthy, and confidential. This is fundamental to maintaining the integrity of any digital environment. Let's take a look at some of the exciting future trends shaping our digital landscape. First, we have computing that is happening right at or near the data source itself, rather than relying solely on centralized cloud data centers. This approach, known as edge computing, allows for faster processing and reduces latency, which is crucial for real-time applications. Next, we have the Internet of Things, or IoT, which is essentially a vast network of physical objects. These are the things, embedded with sensors, software, and other technologies. These devices can communicate and share data seamlessly, creating smarter environments and more efficient processes. Finally, with the advent of 5G technology, we're seeing a leap forward in connectivity. 5G offers high data rates, significantly reduced latency, and energy savings. It also enables cost reductions and supports a massive number of devices connecting simultaneously, which is vital for the growth of IoT and other emerging technologies. Together, these trends are transforming how we process data, connect devices, and build smarter systems, pushing us toward a more integrated and responsive digital world. Let's take a closer look at the global internet growth over the past few years. As you can see, there has been a steady increase in the number of internet users worldwide, measured in billions. This consistent growth highlights how more and more people are gaining access to digital connectivity. Over the last 5 years, this trend underscores the expanding reach of the internet, which is crucial for understanding the broader digital transformation we're discussing today. It really emphasizes how integral the internet has become in daily life across different regions and communities globally. As we look ahead to 2025, it's clear that mobile devices will continue to dominate web traffic. In fact, the majority of internet activity will come from smartphones and tablets. This shift highlights a crucial point. Optimizing for mobile first isn't just a trend anymore, it's a necessity. When designing networks and digital experiences, we need to prioritize mobile performance to meet user expectations. This ties back to our overall theme of staying ahead in a rapidly evolving digital landscape. Ensuring our networks are mobile-friendly will be key to maintaining engagement and delivering seamless experiences in the future. Prepared by Vinod Goswami. You can reach me via email at goswamiv505@gmail.com or by phone at +91 8,755,072,430. And with that, I want to sincerely thank you all for your time and attention. Your engagement means a lot, and I hope the insights shared today have been valuable for you. Once again, thank you very much.